Welcome to the Explainer. Today, we're going to switch on the lights and really understand one of the most fundamental forces that powers, well, everything in our world. Electricity. It's everywhere, we use it constantly, but what is it really? All right, let's get into it.
Think about it for a second. You do this every single day, right? You flick a little switch, and boom, instant light. But what is the magic that's actually going on inside that skinny little wire that connects the switch to the bulb? We're about to break down exactly what's happening.
So, to get to the bottom of this, we have to zoom in. Way in. We're going from this big, familiar idea of, power and light, all the way down to the invisible world of these impossibly tiny particles.
At its absolute most basic core, this is it. This is the scientific definition. So let's forget everything else for a moment and just focus on that one word, flow. Electricity isn't a thing you can hold in your hand. It's a process. It's something that's happening. It's the movement of something called an electric charge.
Okay, so how does that flow actually happen? Well, it all starts with these little guys called electrons. They've got a negative charge, and they're just kind of hanging out inside the atoms of, say, a copper wire. Then, when you flip that switch, a force, and we'll talk more about that force in a sec, gives them a big push. And it's that organized, domino-like chain reaction of electrons hopping from one atom to the next that creates the flow we call an electric current.
Now, if you really want to get how that flow is controlled, you kind of have to learn the language of electricity. And it turns out there are three key ingredients, three main forces that decide how that current is going to behave.
The easiest way to picture this is to think of a river. It's a perfect analogy. Current, that's just how much water is flowing past a certain point. Easy. Voltage is the pressure that's pushing the water. So think about a really steep, fast-moving river versus a flat, lazy one. That's voltage. And then you've got resistance, which is anything getting in the way. Rocks, fallen logs, anything in the riverbed that slows that flow down. These three things are always in this delicate dance inside every single electrical circuit.
Okay, now that we know all about the flow, let's talk about the two main forms that electricity takes. And I guarantee you've experienced both of these. There's that little surprise zap you get from a doorknob, and then there's the steady, reliable power you get from a wall plug.
Static electricity is pretty much what it sounds like. It's static. It's a charge that builds up and just sits there, staying put until it gets a chance to discharge. That's the zap. But current electricity, that's the one that's always on the move, constantly flowing through a conductor. This is the workhorse. This is the electricity that powers our lives day in and day out.
So how in the world did we go from just noticing a little spark to building a global power grid? Our understanding didn't just happen in some single eureka moment. No way. It was this long, fascinating journey of just watching, experimenting, and a little bit of genius.
It all started over 2,500 years ago with the Greek philosopher Thales, who just noticed that if you rub a piece of amber, it gets this weird new property. Now fast forward to the 18th century, and you've got Benjamin Franklin flying a kite in a thunderstorm, proving that lightning was actually just a gigantic form of electricity. But the real game changer? That came in the 19th century with Michael Faraday. He's the one who figured out the link between magnetism and electricity, and that is the core principle that lets us generate power on the massive scale we do.
And today, that electricity comes from all over the place. Nature gives it to us in these spectacular shows through lightning and constantly through the sun's energy. But for our grid, for our homes, we've built these enormous systems. Everything from power plants burning fuel, to massive dams using the force of water, to huge farms covered in solar panels. And all of them, every single one, is designed to do that one thing: get those electrons moving.
So, this incredible journey from a simple observation to a global network, how does it all come together in our modern world? We've managed to tame this invisible force, to build our entire civilization. But with that kind of power comes a huge need for respect.
Just stop and think for a second about how much we depend on it. That light bulb over your head, the fridge keeping your food cold, those massive industrial factories, the electric cars and trains on our roads, even the life-saving equipment in our hospitals. Every single one of those things runs on the exact same simple principle: a controlled flow of electrons. It's amazing.
This force is powerful enough to have built our entire world. And for that very reason, it absolutely demands our respect. And it means we have to follow a few simple but super critical rules.
And listen, this part is non-negotiable. Electricity is always looking for the easiest path to travel, and you never, ever want that path to be through your body. So never touch frayed or open wires, don't handle anything electric with wet hands, and always, always rely on safety devices like fuses and circuit breakers. They are there for one reason, to protect you.
So there you have it. From this mysterious force that was noticed in ancient Greece to the absolute lifeblood of modern technology, we've learned how to command the electron. We've built our entire world on its flow. Which leaves us with one final, big question. As we look to the future, what new sources, what new ideas are going to power the world of tomorrow?